This is the world's first 360-degree solid-state radar produced by Oxford RF for use on automated and autonomous vehicles. The concept was developed following the identification of a common problem that these types of vehicles have.
Cost is the biggest driver in any commercial system. If we want to bring autonomous vehicles to the market, it has to be at a sensible price point. Now, there are too many sensors on a vehicle right now purely because the sensors need to augment each other. There are cameras, there are radars, there are LiDARs, and then you have to put those sensors all around the vehicle.
Oxford RF have been working with the Warwick Manufacturing Group and the WMG internship programme to test the radar for use on autonomous vehicles like this one.
This test car already has 10 sensors, including cameras, radars and LiDAR, to provide 360-degree situational awareness, even in difficult conditions. But more sensors means more cost, more power consumption and more data to process, which increases the latency in decision-making, which is a problem for vehicles travelling at speed. Oxford RF hope their radar will reduce the number of sensors needed.
Radars have the benefit that they can work regardless of the weather conditions, regardless of the visibility conditions. You don't need to clean them. And even if there's a tunnel filled up of smoke, radars will produce a perfect picture of the environment. So it's a safety critical sensor.
Having 360-degree sensors means you need less of them. But until now, they cost way more and were less reliable than those with a narrower field of view.
There are spinning parts in some of the 360-degree sensors, and that sort of increases the cost 10 times over a solid-state sensor.
With less or no moving parts, there's generally less to go wrong in these harsh environments, particularly within automotive.
To enable the building of the world's first solid-state 360-degree radar, Oxford RF applied for a grant from the Advanced Propulsion Centre.
The APC is running the TDAP program, which is one of the best hardware accelerators in the UK. And they are giving us the necessary pre-seed cash support and also the mentorship. And they also make connections for us, which are really critical, access to the market. So there's a lot of resources that the APC is bringing on the board.
One of the great advantages of working with the Advanced Propulsion Centre is they've been able to introduce Oxford RF to major industry partners to validate the market for their sensor.
Today we are exploring commercialization opportunities with some large players in the market for these applications. And looking ahead, this is one of the ideal sensors to enable autonomous vehicles and speed up the process of bringing them to the market.
There's a huge range of potential applications for low-cost, solid-state 360-degree radars inside and outside the automotive sector. This APC-enabled innovation could help the UK become a world leader in a number of strategically important emerging sectors. To find out more about how the Advanced Propulsion Centre is accelerating the development of low-carbon automotive technology, visit apcuk.co.uk.